Okay, I've restarted recording to the cloud. I've restarted recording to the cloud.
Excellent. Thank you. Okay. So how are we on the teacher resources? We've got scope and sequence. We've got approaches to either extend or reduce the time it takes. And then, of course, the assessment materials. So that's, I'd say that's the high points of what are available on our site. There's also another place that you can get quite a bit of resources, and that's at the nycirc.org site. nycirc.org is a Department of Homeland Security funded agency for workforce development, and their grant money gets converted into curriculum that's free to United States teachers. So if you are a teacher in the United States, you can click the curricula access link, and when you do, you will be taken to a form where you just basically tell them, you know, who you are, what you teach, what your contact info is. And so here's the request access link right here. See if it's also.
Can anybody see what he's doing? Because I can't.
I don't see anything either.
All I see is the desktop
gray and white
icons.
box.
Mm-hmm.
So you've just zoomed in the gray and white box. Ah, there we go.
Hey.
Okay, I'd better back up just, well, okay, nycirc.org, NICERC.org. And in our slideshow, I'm on slide 39. And so what I did was
Based in my hometown.
Yes, indeed. Have you been to any of the earlier EDFs that were held there?
A couple of them, helped work on some of them too.
All right.
Great.
I've been to 2 of them, but not in Louisiana, even though I'm from here.
I joined them up in. I joined them up in Denver this past summer.
Okay,
Oh.
yeah. So
Yeah, me too.
Did you guys take the Cyberbot class from, was it Ken and Tommy by chance?
Yes, it was Ken and Tom.
All right.
I took some with Ken. Yeah, I did some other programs too.
Yeah, it was great.
They've got several going in parallel. It's an outstanding thing. So here we are at nycirc.org, and it's kind of in small letters, but there is a request access to curricula. So I went to curricula access, and then after doing so, here it puts me, oh, here we go. So here is the sign up form. And so it's a very simple sign up form. It only takes a minute to do, but after you've done it, they'll send you a login, and when you log in, you'll basically get a Canvas dashboard, and there is just a whole lot of curriculum. And so, for example, here in CyberLit, you can open that up, and then the CyberLit class has options for Bobot, Arduino, or Cyberbot. So for example, if you wanted to teach some electricity components with the Arduino and the ShieldBot, you could follow that. And then you get a number of downloads. So all of these are downloads for your teacher notes, your PowerPoint presentation, and the Arduino ShieldBot features prominently in many of these classes for cyber literacy, cyber science. I think there's a physics one where I mentioned that earlier, that they were doing tests with how much a servo could lift by making it into a little winch. And yeah, physics right here. And so that there's some very advanced lessons you can do with the ShieldBot, and and then the curricular support that NYSERC offers. So I highly recommend, in addition to being signed up to the Parallax site, to using this as another resource to get whatever you need in terms of support for classroom stuff. How's that so far?
Are any of you California teachers?
Yep.
Okay, one other thing here you might be interested in is our A to G certification for our small robot courses.
Now, are you sure about that? It looks like you're from Pittsburgh.
Pittsburgh, no H, California. Every dang time.
I will say, with if you do the cyber literacy stuff, I don't know how everybody else's schedules run, but I have my kids anywhere from 3 to 4 times a week. And I did cyber literacy last year and this year, and just doing that one course is not going to cover the whole year. So I do cyber literacy 1 in the first half and then 2 in the second half. And I still like sprinkle in stuff that just I want to do, because it doesn't last my entire like 75-minute 3 to 4 times a week class period. If you're on that kind of stuff, so want to do, and I'm high school, so.
And that's block scheduling then, yeah?
It's a rolling block, yeah. So I'll see them like 3 to 4 times a week for 75 minutes, and because it's high school kids, they catch on to things a little bit faster. And so it just not like some things that you're like, oh, it's going to take 60 minutes, takes like 40. So
yeah.
But you can kind of sprinkle in your own stuff.
About classroom management, something you think is going to take 5 minutes takes 20, something you think is going to take 30 minutes takes 10.
Yeah,
please feel free to email us about our scope and sequence too. If you end up using that and you see that something takes a lot longer or shorter than expected, we'd love to hear about it so we can add notes to it.
Yeah, and the cyber literacy stuff has other stuff just besides like the robotics too. It has like liberal arts type of assignments because they are with Homeland Security. So they've got like extra bits and things in there. So it's not every single day like coding, robotics type stuff. It's kind of like a variety of things.
Okay.
Yeah, they also have some contests in a RARC category. So yeah, with the Arduino, I flashed on it there for a second. See RARC in the classroom. So this would be where to find some contest info also. Anyway, join or sign up for this and make sure you've got it available as a resource to use. Okay, so that is everything. Oh, Stephanie, did you have anything more to say about the California curriculum?
Oh, I just pasted in the link for
Okay.
the A to G certification that applies to our small robots, including the ShieldBot, for any California teachers that are interested, or if this helps make a case for you if you are trying to make a case.
Thanks.
For a ShieldBot. Thanks.
So, and that's coming up on the screen just now. So here is our A to G certification, and that applies to this book that you're in, along with any of our other robots. I didn't realize it was for What's a Microcontroller too. That's cool. All right. Okay, so that is curricular resources. Now some cliff notes or actually, Stephanie, did you want to do the awards ceremony first, or should
We'll
I?
wait to the end.
Oh, okay.
Because I want to ask people about their experiences first after you go through the cliff notes with what they
Okay.
did.
So briefly about light sensing. So we start off with this light sensor because it's kind of everybody's first light sensor. And it works, but the catch is that you have to change out this resistor sometimes because it may be too dark or too light in your room. We chose one that's kind of middle of the road. And what happens with this resistor is the amount of sunlight that hits the resistor, or the transistor, pardon me, is that's this clear part right here is a transistor. And the phototransistor, the amount of light that hits it, is what controls the amount of current it allows to flow through this leg of the circuit. And so with more current, there's this nifty little thing called Ohm's law that I think I really didn't put in the right spot. A nifty little thing called Ohm's law, where the amount of current times the resistance is the voltage that you'll see right here. And so what we do circuit-wise is we say, well, gee, is a lot of current going through? Then there's a lot of voltage, means a lot of sunlight. Is there only a little current trickling through? It's a little bit of voltage, only a little bit of sunlight. And so it is a good first lesson, but I do want to caution about using that on a robot that might go from one room to another. You'll end up running into some challenges with that, but we have a solution in the book. This is the voltage measurement example, and I put the code in here, and it's pretty simple. It's basically we have a little volts function down here that takes the A to D measurement and changes it into a voltage that you can display on the screen. So that's where, 1.08 volts and 4.09 volts and all those kind of things. So the voltage varied on this display as we varied the amount of light that we allowed to hit the phototransistor's light collecting surface. The slightly more advanced, but also much more capable way is to use a capacitor in a pair of capacitors in a pair of circuits that look like this. When you do this, what happens is that your code can play this neat little trick on the circuit that measures the amount of time the circuit takes to respond. And in this circuit, that's controlled by the phototransistor. Normally, I'd go into more detail about that, but with time being what it is, I think I'm going to skip over that, but I would be happy to follow up with anybody who wants to talk about that. The short of it is that this particular circuit, after experimenting with the voltage one, this particular circuit will give you times that, it'll even give you times in low light or high light situations. It doesn't matter. It's very flexible. And if you use a pair of them together, you can actually just do it in a ratio. So this ratio up here, just think about this ratio for a second. What if T left and T right are equal? So let's say this is 20 and this is 40. Oh, gee, look, we've got 1/2 or 0.5. And so because they're equal, we can call this 0. Now, what if T right is super large and T left is kind of small because you put a lot of shade over T right? Well, maybe 1,000 over 1,000 plus 10, well, that's almost 1. So now, but then if we do T left, okay, so now this is 10 and this is 1,000. Well, gee, it's almost nothing. So we get negative 0.5 instead. And so what you end up with is this ability to go back and forth actually between 0.5 and negative 0.5. And because of that, because it's a relative measurement, it becomes really easy to make the Bobot steer. And our running joke in the office is that we're making shady decisions about which way to turn, because we're turning away from the shade. And then you can adjust the program to also turn away from light instead. So that's just a kind of a quick summary of our light following, and the book really does go into a lot of detail. So, but if you have any questions, we really want to hear from you. And if you also see any problems, contact editor@parallax.com. Yesterday, did I talk about how a TV remote makes a light flash? An infrared light flash. Did I mention that before?
You talked about each project individually, and yes, you talked about the remote when you were asking for the people who have done the whiskers 100 times to do the remote or the light following. Okay, excellent. And so since the remote flashes the light 38,000 times a second, the way the remote gets the message across is it says, oh, look, it just flashed on and off at 38,000 times a second for 2.4 milliseconds. And then, oh, after that, I see 0.6 milliseconds of flashing on and off coming in, and then another break, and 1.2 milliseconds. This 0.6 right here is a binary 0. This 1.2 milliseconds of flashing is a binary 1. Then here's another binary 0. And that's how
that's how the TV remote sends messages across, just as an interesting for your information thing. And then we talked about how the flashing light will either go off into nowhere or bounce off something and come back to the receiver. One of the things that I like to do with document cameras or cell phones is some of the cell phones or doc cams will actually show you the light that a TV remote makes because they don't have, iPhones tend to have infrared filters. So you might not see anything if you have an iPhone. Then again, you might. It's hard to say. It depends on the vintage, and likewise with the Android phones. But it's worth a try, and your doc cam is also another one to try if you have one of those. Be careful. The photo transistor is clear, as is the infrared LED. It's just that the infrared LED has a bigger, more pronounced dome shape. So take that one and put it in the tube. And then once you have put that in the little tube, you can build the circuit. And this circuit is very important to test. One of you tried to contact me, and I was not able to get back to who, George, I think it was, said, hey, my left infrared circuit is not working. The right one's okay. Can you contact me? And the answer is I will try to follow up with you after this, but I just did not even have a moment. Sorry about that.
Okay, that's no problem.
Yes.
I have a question. Looking at the infrared LED circuit, the schematic over on our left, bottom left, why is there a 2K ohm resistor in the LED circuit as opposed to a 220 ohm resistor? Why so much?
Okay, the reason it's so much is because basically if you put a 220 in there, when you flash this LED on and off, the light is so bright that it bounces off like the surface in front of the robot and comes back to the TV remote. So we actually had to use a larger resistor just to tone it down because the infrared LED relative to this receiver was way too bright. I mean, sure, it would be, if it was a red LED and we use this 2K resistor, it would be barely visible. But because of the fact that it's an infrared LED and the viewer is this little TV receiver here, it was way more sensitive. So we had to make the headlight less bright.
Okay, thanks.
Sure thing. Excellent
There's
question.
also, I don't know if y'all have in y'all's curriculum a kind of write up for the kids on like changing out the resistors to kind of see like the distance.
We do.
Yeah, it's real cool, and they like it because it makes them more aware of like a sink when you walk into a bathroom, why it just like turns on and you're like 10 feet away from it, or like why you can't get any water, and it kind of links it to an everyday item too.
Yeah, that is in the book, and they actually go through with, I believe, a red LED first to see the change in brightness. I may be confusing my books. It's either that or they just see that by using larger resistors it becomes less sensitive, and by using smaller resistors it becomes more sensitive. And then Stephanie will hate me for this. I put her picture there checking for fluorescent lights. I was actually sitting across from her. Did I take that picture, Stephanie? I guess it doesn't matter. But anyway, there she is checking for fluorescent light interference because ballasts in fluorescent lights will sometimes interfere. And so especially during contests, you want to try to check that if you're relying on infrared. Let's see here. Fast IR roaming. I just threw this slide in because I highly recommend trying fast IR roaming. You can also point the infrared LEDs down, and instead of turning away when you see something, you keep going when you see something and only turn away when you don't. And black electrical tape on poster board works out pretty well as an apparent drop-off because it absorbs infrared. So if it's shining down, you don't have to take the risk of actually falling off a table. You can just kind of make simulated drop-offs by using black electrical tape, or black Cove base works really well. And then just a quick note about the infrared distance detection. This diagram right here makes it seem like they're really great distance detectors, but this is an exaggeration. It's really like you get an inch or two, about 6 to 8 inches out of distance detection, and that's about all it is. And what we do is we take advantage of the filter. If you flash the light, the IR LED on and off right at 38 kilohertz, the receiver is 100% sensitive. But notice if you change the frequency to say 39 kilohertz, it's down to 80%. And by 40 kilohertz, you're approaching 50% sensitivity. And so by giving it different frequencies in a little for loop, you're able to successively make the infrared receiver more sensitive. So you send the best frequency. Did I see it? Okay, great, I saw it. Then the second best frequency, still saw it. Then the third best frequency, didn't see it. And the fourth and the fifth didn't see those either. And what that ends up translating to is a zone of 3. And essentially, you can count the number of times you don't see it, and that'll give you your zone. And then here are the zones in the terminal while you're testing. And then here's a little capture of the code, which I can't take time to talk about, but again, it is described in great detail in the text. We also do control systems. Basically, we're saying, well, gee, I have a number between 0 and 5, and I want to keep it at 2. Well, if I got 4, that means I'm -2 off from the distance I want. And by doing a little bit of math and multiplication, we know that we want to go full speed forward to try to get towards that goal of getting a distance measurement of 2 the next time around. We also have cool applications like a rotating ping ultrasonic sensor. If you want really good distance measurements, this thing is great.
This is one of the projects, as is the IR remote controlled shield bot, that are considered the extended units from the scope and sequence.
And they are all in the projects section of the Arduino online book at learn.parallax.com. And so this is the online version of the textbook you've been working out of. And like the PDF, it's kind of nice because you've got full color illustrations. So all of those projects are down here. This one's fun. It's it will meow at you to ask you to get out of the way. And the Pixie Cam is new, and that's kind of a neat little application. So these are optional add-ons that you could try out. And go ahead.
When we went to the Denver NYSERC convention in Denver, one of the coolest things that they did is we did this afternoon meet and greet where they had some food and some drinks. And they had about 7 or 8 robots just navigating the floor using the different sensors, using different types of tires and wheels and stuff like that. And they were going out of the people's way, going around them and stuff like that. It was really cool to watch just the multiple robots using the different types of distance censoring to get through the room.
That's a lot of fun. And so you can have the students, we also do that in educators courses, like if we have people actually meeting as opposed to this remote thing, we will have different people build up different circuits, and then we all get together and demo our different, the one that we built. And yeah, so that's cool. So if you can encourage your students or set it up so that they have kind of an open time where they can create something that they want to feel proud of, and then have it interact with a group of other robots. There's also some hilarity when 2 run into each other and stuff like that. Okay, so we also have on our Parallax website a list of devices that we sell that are known to work well with the Arduino. And again, I linked all of the slides that I've been showing you where it has there are many of them have live links. You just click the picture and then the link should appear below. And when you follow it, you can see all the things that you can use with the Arduino on your Shield bot that we have. So if you want to be able to clap your hands to make the robot go, here's a sound impact sensor. If you want to follow a color maze, here's your color pal. PIR sensor, so maybe it'll move only if somebody walks into the room. and so on and so forth. Great displays, little joystick. They're all compatible with the Shield bot. The Shield bot also can be converted. I grabbed this slide from our Cyberbot presentation. So in a Cyberbot centric look at the thing, well, gee, you can take a Bobot or a Shield bot and convert it to a Cyberbot, but the reverse is true too. You can pretty much convert between any of these three. The multi-core propeller activity bot is the only exception, where the conversion kit is, I think, $70 or $80. Whereas the rest of these, the conversion kit is generally like just the difference between the number of batteries it holds and then the shield that you have on top, whether it's the Arduino shield or the Cyberbot board with the microbit. Any questions on that?
Is there a reason that we use all of the AA's versus using like a 9-volt with a pull down resistor?
Yes, we used the 9-volt early on. 9-volt capacities are not as good as 5 AA's. So 5 AA's will keep you running for a good long time, whereas the 9 volts, that's a lot of really small batteries connected end to end inside that case, and they get tired really quickly by comparison. So
I find that like half of a year with running for a good 75 minutes, 3 to 4 times a week, and we change the batteries towards the end of the year, unless they forget to turn it off and don't unplug their battery pack. Then they burn out in a weekend.
I'm glad you mentioned that, because I forgot to tell you all about this. I did a lot of battery shopping, and
now, unfortunately, this one doesn't work with the 10Gs, right? Because this one, because the Arduino requires the higher voltage.
Okay, yeah, it doesn't technically work. You're right. Shucks.
It's not supposed to work with them, and it probably dies faster if you're using the rechargeables.
Actually, the nickel metal hydrides are pretty good. The NiCads not so much, and the 10Gs are excellent, but the Arduino requires the higher input voltage than our breadboard circuits and actually the servos need, unfortunately. So that's why with the 5AA pack, that's not something that we have listed as a recommended accessory for it.
Yeah, so regulated at 5 volts, the servos are fine.
Mm-hmm.
But yeah, I think the Arduino is just a shade under what the rated voltage of the batteries are. Okay.
Mm-hmm.
Well, I'm glad to hear that your alkaline batteries have been lasting a fair amount of time. Has anybody been using rechargeable batteries with a 5-cell pack?
In this robot? Nope, no one's tried it.
Okay. I do it all the time. So much so that I forgot that it's not technically something you can do.
Okay, so secret, it does actually work.
Yeah, give it a try, but use really.
Yeah, but they overheat. Lisa says she has, but they overheat.
Oh,
that sounds like a short circuit type of.
Which type are you using, Lisa?
I had a kid's overheat one time, and we figured out it's like after the fact, after we like let it sit for a day, unplugged completely, because his was plugged in and on 3 full power for like an entire day. So
okay,
yeah, that's the only time I've ever had any batteries overheat.
So
I'd love to see like a rechargeable battery pack like you see in an RC car or something like that. The actual something wrapped and attached that you just plug into a charger and then plug off the charger and you're good.
Yeah, those are nice. We don't have the kind of, you'd need some kind of adapter to get to our center positive 2.1 millimeter.
Yeah, that kind of battery also has a tendency to catch on fire when it shorts.
Okay, so. Yeah, let's avoid that one.
But that's the best part.
That's the best part, man.
Take it from somebody who's cleared out a dormitory twice.
No.
Doesn't make you popular.
Okay, no, definitely.
Well, that you got to tell the joke that if you let the magic smoke out of the electronics components, they don't work anymore.
Yeah.
There's one other caution that can go
That's
wrong.
a Ken joke, yeah.
When students are assembling the robot, sometimes they use a pan head screw instead of the nylon flathead screw to attach the battery pack to the underside of the robot. That's not good for two reasons. One is the flathead screws are recessed so they don't nick the battery, but if you're using a panhead screw, it can nick the battery cover, and some of those are actually, if you nick the cover enough on the battery, it'll make a connection, and since it's a metal screw, it'll ground it to the chassis. And that has happened, we've seen that happen where everything's gonna get rather hot rather fast because they've damaged the battery and grounded it. So that's why there are nylon flathead screws in the kit. And in the class, if you're having the students assemble them, it would be worth doing a battery pack check before proceeding from that step.
So has everybody got, I was trying to get to the visual support for that, but I didn't make it in time.
That's okay.
Yeah, let's just be really careful though, because yes, the nylon screws are the ones you and your students definitely want to use for attaching the batteries pack. Avoid using any metal screws because it actually can nick that battery cover pretty easily. And then what you get is a short between the outside of the battery, which might be at 3 or 4 volts, and then the ground of the chassis. So yes, very important to double check that. Our educator hotline is all over our site, and so we encourage you to call that if you get stuck or need some advice on, you know, gee, I'm curious about how to implement, you know, this curriculum. What are your insights on it? You'll get Ken's phone, or you'll get me or Stephanie. And yes?
Jerry says he's leaving.
Okay.
Thank you.
Thanks for coming. Yeah, we ran overtime because we got to such a bumpy start. Stephanie, did you want to give out the awards?
I did want to very quickly do that. So our 3 categories for awards were our favorite coworker, our biggest fail, and our biggest win. And I hope I didn't miss any submissions for this. So we got just flooded from emails from all the courses on the subject.
Stephanie, do you want me to share your screen?
No, that's okay. I don't have a good way to point to anything in particular, but I will just give a shout out to Michael Yenner. Is that the right way to pronounce your last name?
Yes, that's perfect.
Great. Who shared Amy White, who shared Michael Yenner from her Cyberbot class. So they have shared each other. And so which is awesome. So we figured that is award worthy there.
And what is the award?
A ping and bracket kit, so you too can make your shield bot into a hobo hitchhiking to Maker Faire that goes with the little YouTube video that we have there that Andy just recently showed. That's me getting silly. When I get a little stressed out, I dress up the robot. So to start anthropomorphizing everything.
Which means they get dressed up for Thanksgiving and New Year's and
4th of July and so forth and so on. And then, okay, Michael with the Caterpillar, can you pronounce your last name for me?
Oh, Wilkos.
Yes, and so you sent me your application. Can you tell us a little bit about that?
Oh yeah, so like before my son was even born, like I saw the Caterpillar. Hold on, I'm gonna go get it because it's right on the table. So
I like the Caterpillars. I've seen those. I used one of those for a Girl Scout code badge.
And so I wrote modules. I'm in the process of writing modules. I don't have everything done yet. So he can put this together and then I can throw the procedures, and I've timed it pretty well as long as the batteries stay level, where mine will follow him if I see the way he puts it together, and they'll go in pace with one another and drive in mirrored fashion.
So I think that this robot interspecies friendship is a wonderful thing. And so I have to give a win for your trying that application. And then I just want to hear from you guys. Who has a biggest fail when they were working with their ShieldBot this week that they want to be the first person to raise their hand and tell me about?
I left my batteries plugged in overnight on Monday to Wednesday.
That's a pretty universal one, though. I don't know if we're going to give you a second award for that one.
I
dropped mine off the table, and a lot of things popped off of it, and I thought I might have broken it, but I didn't. So,
so durability test. That's a good one.
Yeah.
Thank you for that.
Dropped
endorsement.
my screws that I was attaching the board to the chassis with, and I had to go find a magnet and climb underneath the desk in order to find them. But that was about as crazy as it got for me.
So a classroom tool recommendation is a magnet on a stick for finding small bits. That's a good one. That's a
I
good
think
tool.
it needs to come with the kit because of how many times you hear that dropping click noise as the kids drop the bolts. I can't tell you how many times that has happened. I pretty much went to Harbor Freight and got a big magnet on a stick, and I keep it in my classroom, and I go over my classroom at the end of every class period
Oh, wow.
bolts and a whole bunch of different things.
I will, and I've heard Lisa use the vacuum to find a missing screw. I will quickly paste in here a link to our small robot hardware refresher pack that has all of those little bits and pieces. And there's one of these also, one or two included in our 12-pack plus for just emergency situations.
Good sales pitch. I'm waiting for the, but wait, there's more.
I think I have a tendency. I think I have a tendency to shed screws and nuts because every time our janitors come through my workstation, I hear this whack whack as like several screws go up their vacuum cleaners, and it's
and my vacuum cleaner at home too. Okay, and then Nikki attached the standoffs to the wrong hole, assembled the entire robot, but realized that she couldn't attach the Board of Education shield without moving them. Instead of removing the screws, the robot still has the screws in the wrong place and added the new screws and moves the standoffs. There you go.
That works. Yeah, make it work.
Adaptation. Nice. I'm liking these stories.
Modern problems require modern solutions.
Yep.
Exactly.
My bot was it was every time I used it, it would spin and spin and spin and spin, and I couldn't get it to stop until I realized that I had been fiddling with the adjustments on the servos, and once I turned down and then I had to go in and readjust the servo to get it to stop spinning, and it worked.
Oh,
yes,
wow.
and that is a classic student symptom.
Insert one above. Wow. I don't know. It's going to be hard to pick a biggest fail out of all of these. These are all very educational and instructive.
Shall we take a vote?
I don't know. I think we're just, who is it who had the magnet one there? That was Jamie. Okay. I think I'm just going to send you all a remote.
All of you who failed just won.
Yes.
That's hilarious.
Just because that'll give you the opportunity to do that other activity. And I really,
yeah, so you can do, by the way, the remote is the same as the infrared circuit. So if you do the infrared activities, you don't need to make any changes at all. You are ready to run the remote code if you have this circuit up and running. And so, yeah, I recommend that.
Thank you for correcting your name, Robert. And Emma down there, Nolan. So
yeah.
hijacking family members' computers. Cool.
You can rename yourself in your Zoom session.
Oh.
What happened?
Y'all can
I haven't
rename
figured
yourself.
that button out yet.
Aha.
Well, I want to just thank you for everybody for sticking through this in spite of our various technical snafus that we had to overcome. I really appreciate it.
Yes, I do too. Thank you very much, and I'm really glad you all came. And I hope this was, had some little gems of information for you.
Oh,
Really great.
yeah.
Yeah, it's been great for us too. You were about to say something, Stephanie?
Oh, Michael just changed his background to show that.
Yeah, I found that earlier. There's the picture of the Bobot with the Caterpillar. And then I found out that there's a new version of the Caterpillar that has potentiometers on each one, so you can choose between one of 4 things, 3 of them being a direction forward, left, or right. I may have already bought it for my son.
And Ken is here. Ken, if you could unmute maybe and answer the question, will there be other similar sessions?
Absolutely. You guys tell us what you'd like and we'll arrange them. Otherwise, we just kind of come up with our own ideas.
Okay, Kimberly, you're muted.
I couldn't unmute myself with the space bar, so I was throwing me off. Anyway, Utah is doing online learning, meaning we are still teaching school despite this lovely COVID outbreak. Do you guys have any suggestions for teaching robotics to students who are at home who have no access to the robots themselves?
Are they able to see you through a Zoom through an interface live?
Yes, they could do Zoom. We also do Google Meet. But like as of right now, I'm using the Tinkercad software to specifically go through and teach electronics online. And that is the best method I've figured out for the electronic side of things. But I'm trying to figure out how to get them to do the hands-on robotics side with not allowing them to have like their own robots in front of them that we provide them at the school.
All I could think of at this point is to have them write code and then send it to you to run on the robot that you have and see how it works. So you could challenge them, and you could start with code that actually works and then ask them to make modifications. And so if code to make a square looks like this, what would code have to look like to drive in a circle or drive in a triangle? Some of those challenges.
We've been using MIT's Scratch because it's got a simulator of a turtle bot. So that actually lets you go in and set up code blockwise, and you can do things like etch-a-sketch drawings and obstacle avoidance, and you can actually go pretty far with it. So it's that's what we've been using.
I've had them do the code.org express course, and that's it sounds fairly similar. It's not exactly the same. But
I'd give it a look because they've got curriculum and lesson plans already developed, so it's pretty nice.
There's another one that's actually happening at 7 o'clock Eastern Standard Time. Vex Code is doing a rollout of their virtual environment, so that's where I'm going next. So you program either in blocks or text, and then you get a virtual environment to test the robot out in.
Could you send a link to that? Michael?
Yes, I'll get you the link to that. Vexcode VR.
Yeah, but did they make that one free yet, or is it still pay?
I think it's going to be free through the end of the year because of COVID.
Good thing this COVID broke out.
Yeah, that's.
There's the silver lining. Yeah.
It makes undie teaching a whole lot better anyway.
I have a question for Ken and Andy and whoever else can answer this. One of the things that we do is we participate in the NYSERC competitions for robotics. And sometimes we have multiple programs that we want to build on top of each other and be able to activate the program when a certain task happens. And one of the things that we have in the kit is the little button thingy with the 4 prods. I tried calling the hotline at one point, and I asked them about the button and what kind of program we can use for the button. They said they'd get back to me in about 2 to 3 days, and it's been about 3 months. But my main question is, are we able to use this button as a different part of the program to where run this program and then wait for the button to be pressed and then run the next program and then wait for the button to be pressed?
Yeah, let me, yes, absolutely.
Because I don't see that anywhere in the book.
Yeah, I don't know that the book talks about the button per se, but the button can be wired identically to a whisker and then read identically to a whisker. So let me see if I can get to a slideshow quickly enough. Is my screen shared right now, or did the share get turned off?
It's the gray and white block right now. It's not your screen. It's not fit on the screen yet.
Okay, so that is the wrong screen. Okay, I'll bring it down to the right screen in a second.
Alternatively, depending on the circumstances, an IR remote can be used to change modes. We do that with one of our IR remote applications. We have it to where with the remote code, we switch it from IR remote control to IR roaming to IR following.
Remote controls cannot be used at our competitions. That's where
okay.
What my students have been doing is downloading, they're bringing their computer to the competition mat with them, run the program, download the next program, run that one. And since you only have about less than 2 minutes to complete as many tasks as possible for points, trying to institute the push button would actually save us a lot of time.
Oh, it would. Okay.
Yeah, the push button is really easy to use to advance modes. You can certainly try it out with a whisker also, because yeah, the circuit can be, like I said, wired up identically to the whisker. I'm loading up a presentation. Let me see if you can you see the did something just become visible on your screen?
No,
it still shows your icon. Oh, there it is.
There we go.
It's up.
Okay.
Well, half screen, but yeah.
There we go.
Hey, thumbs up.
Yeah, so it's still loading. And eventually when it gets loaded, I'll be able to show you the circuit that you can wire. And this particular circuit will be the inverse of a whisker, in that when you don't press the button, you get a 0. And when you do press the button, you get a 1, whereas with the whisker, it's in reverse. Okay, looks like things are starting to load. Has my audio gone out, or has my audio been okay through this?
You're still good.
The audio's been good.
Okay. So I'm not sure why this is taking quite as long as it is to load, but the yeah, the background is that I've been drawing new circuits and applications to make a let's get started more quickly thing doable. And so what we can do is send out some example code with this circuit, some example Arduino code.
Hey, just for an FYI, Vex does have that environment up. You just have to get the VR code reader.
Yeah, I gotta get going too.
Thank you, everybody.
Okay, I'll go ahead and send out the circuit and the example code for using a push button to advance to different modes with the Shield bot. All right, folks. Well, thanks so much for coming, and we really enjoyed working with y'all, and I hope that we can do this again soon. And I know that we're going to have more remote classes coming up, so please keep your eyes open for emails from Parallax, because we'll be announcing some interesting things, and some of them you might find would be right up your alley. So we'll have a variety of things coming, and then also keep in touch with me about anything as it comes up if you're using the Shield bot in your class.
Thanks a bunch. Appreciate it.
If I were to send you, at some point, I'm going to try and do a grant to get a classroom set of 12 for next year. If I were to send you some language, would you just give it a once over? It's due at the beginning of June.
Stephanie, that's you've done similar things, haven't you? Or
I actually have not, but I don't see why not.
Okay.
All right, I'll email you about it and see what I come up with. I've got a template that I can follow, because pretty much I get a cool grant every year for different things. Like last year was VR rig. The year before that we did a set of Raspberry Pis. Before that we did 3D printed hands for enabling the future.org. But I pick a different thing each year, and I think this will be something they will like.
Great. Yep.
All right, thank you so much.
Thank you.
Thank you.
Okay, I'm going to stop the recording.
Okay. Well, since, is it Jamie?
Yeah, it's
Okay.
It's Robert.
on Jamie Gallen's account. You can call me Jamie. I'm used to it.
Because I'm remembering Robert from a previous session. Is that right?
That's me. Yes, sir.
Okay.
For some reason, even though I logged in using my account, it came up as Jamie Gallant, which is my wife's account. So
I see. Okay. Well, I'm almost there. I seem to be able to navigate this slideshow, albeit slowly right now. So I know I'm getting close to, looks like I just passed it.
and this is the microbit, the Cyberbot.
Yes.
If you're curious about those or the activity bot, the sessions were recorded and posted on YouTube for the other trainings as well. So if you want to peek in there. So I know that NYSERC is very involved with the Cyberbot as well.
Well, we actually had a lot since I'm a middle school teacher, but my 8th graders actually compete on the high school level while my 7th and 6th graders compete on the middle school level. Where middle school, they use the Lego EV3 and NXT, while the high school, they use Parallax versions of the robots. We originally started off with the Bobots, but we've had a lot of issues with dead reckoning on those. So we went to the Cyberbot. In fact, I wrote a grant using the Cyberbots and got a class set of them and had a lot of issues with them, with dead reckoning and the Python and that kind of thing.
The same servos. So for dead reckoning itself, the Cyberbot isn't going to perform any differently there. Yeah, the activity bot is the one that has the feedback 360 servos that have the built-in encoder feedback, position feedback. And so for pure dead reckoning exercises, that would have been a better choice. It is possible to upgrade a Cyberbot with the AV360 servos. Andy has included an option for that if you wanted to get a pair and try it.
Well, what we ended up doing is going up to the, I wrote a grant and got it for the Arduino Shield bots. And y'all sent out the email saying, hey, do y'all want to learn how to use these? I'm like, hey, that's perfect. So what I've heard from other high schools in the area that are competing is that for dead reckoning, for precision, and for easiness and programming, it comes to the Arduino Shield bot. So I've learned a lot in this training, especially about different types of programming tricks. When we went into the yesterday, that was very helpful. But my kids would love to learn how to use the button in order to help them with shortening the program. In other words.
Okay. Now again, the Bobot, the Shieldbot, and the Cyberbot are all using the same servos.
And so hopefully that trick about backing off by 100 on the faster servo as the first step, that one is really going to help them out, because what they'll want to do is just you know, do as much as they can to use the numbers to control the servos that correct that lag, or you know, that slow down the faster servos to straighten out its path.
And,
are you still there?
Yeah,
I'm still here.
I'm putting the link in the chat about that feedback 360 servo, just in case you're curious. They're at like they're on sale right now, because a Cyberbot can use that as well, and then you don't have to deal
Is
with
it
it quite
$20 individually, or is that a pack of 2?
That's individual, and they're actually usually much more than that. These are a custom design that Andy specified, and with the built-in encoders, it's like having the accessory of an external encoder, but actually even better performance than that. So I don't know, Andy, how that would work with dead reckoning with the Cyberbot, but that's just the first thing that came to mind.
Yeah, I haven't tried it personally, but I think it would be worth a try, definitely. So here, Robert, is the is a push button activity that, you know, I plan to send out. So basically, if you look at that push button, you see how there's a couple of legs sticking out the side. Well, each one of those is just a kind of a wire that's bent into a horseshoe shape.
Mm-hmm.
And then the button that you push down has little legs sticking out of it. And when you push it down, it compresses a spring, and then you end up holding it against those two horseshoes. And what that does is each horseshoe is plugged into a different row on the breadboard. And when you press down on the button, like see how one horseshoe is on this row, and then the other horseshoe is on this row. So when you press down on this button, you end up shorting this row to that row. And this particular circuit right here, so forget about this resistor and forget about this LED. The rest of the circuit, if you just look at the 3 volts, so what that means is that basically P8 is what's connected to the push button. See how P8 is right there?
Mm-hmm.
Okay, and then there's a pull down resistor, and what that does is it prevents P8 from being like an antenna, and it forces it to 0 most of the time. So P8 sees, I need to fix that. It says P3 over here. That's no good. Yeah, so P8 sees ground, but then when you press and hold the button, you're shorting this horseshoe to that horseshoe, and now you've got 3 volts basically sitting right here, and then it's also trickling through this resistor. And so you get a 1 when you press and hold it. If you say digital read with your Arduino, you get a 1 when you're pressing it, and then you let go and you get 0 again. And so your code can basically say, well, you know, if P8, if digital read on P8 gives me a 1 back, I want to switch to the next program.
Okay. So if we wanted to have 3 different programs saved onto the Arduino, we might need 2 different buttons. So when P8 is pressed, run this program. When P2 is pressed, then run the 3rd program. And if neither buttons are pressed, then you're going to run the initial program.
Yeah, the other thing you can do is have, you can repeatedly press and release the button to advance to the different modes. And the way that works usually, though, is you have several lights to show you which mode you advance to. Or, yeah, so if you have 3 modes, you'd want to have 2 lights, and then you could have all off, 1 on, the other on. You could actually show 4 modes with that.
Wow, okay.
By, you know, because you have 4 combinations to do 2 lights. And the cute thing about that is it's a binary counting lesson, because you have 0, 1, 2, and 3.
Well, I appreciate you taking the time, Andy. And
yes, it's always a pleasure.
Miss Stephanie Lindsay, appreciate y'all. I'm really looking forward to. Sadly, I can only play with one of my robots right now. The other ones are behind a locked door at the school, and they won't let us on campus anytime soon. So I look forward to playing with this one and seeing what other resources and YouTube videos I can find. I look forward to whatever you send out, Andy.
Okay, yeah, I'll basically send out a little thing that shows how to select different modes using the. Do you mind if I just kind of have you toggle through modes on the serial monitor just as a proof of concept, or do we need to like actually make sure that we're doing the lights, or how would you like to do this?
Whatever's easiest on you, Andy. If the serial monitor, I think that would be the easiest. Trying to add the lights into everything would require extra resistors and stuff like that.
Okay. Yeah, so, as long as you feel like you can take it from there, that's my main thing.
And I've been taking the programs out of the book and adding them and playing with them more and more. So if you at least give me a basis form of the program, then I can start playing with it and adding stuff.
Okay, awesome.
Well,
All righty.
I got to go now, but we'll see you next time we see you.
Okay. Enjoy.
Bye-bye.
Thank you.
All right, Stephanie, do I need to shut down the meeting?